All right. I think at this point, ads should be closing up, finishing up all that stuff. Just want to set up my monitor in a way that I can see any incoming comments. How has everyone's Global Hack Week been? I know it's been very chock full of information based on running today in Global Hack Week a couple times. Y'all have had a busy week. Also realized I forgot to set up my music, so I gotta go do that really quick. Otherwise, it's really awkward hearing myself talk. All right. There we go. That is just not completely silent. Well, if you haven't had a chance to check in, I dropped the link in chat. We've got a very busy hour ahead of us. This is unofficially, but also officially a continuation of that intro to Python workshop that I gave back at the beginning of it, where we talked about a lot of different libraries and we started doing some XKCD stuff. I had not prepped that part, so that actually is something we're doing today, as well as more so how you might actually interact with it. Now that you've already gone through a couple of practice rounds with like UT and your finance stock analyzer, as well as I got definitely a lot of other workshops like getting into AI and LLM. You've probably started seeing Jupyter as well. So I figured we'd continue on that process. And like I said, this is a chock full hour where my goal is to remind you of some of the basics if you haven't had a chance to go over them, but you like vaguely remember, or just expose you to them so that way you can kind of practice on your own and then pivot from there. So again, very busy hour ahead of us. Hello, 404. Dare I ask what time it is? Uh, So first on the chopping block, we have XKCDifying your plots. I finally did figure out some of what was going on, and this might vary depending on your version, but it turns out I needed to like remove some cache instances and force Matplotlib to redo rebuild its cache. And so there's a couple links to XKCDify things, and if you're not familiar with XKCD, then you may have seen like these stick figure like comics that are very intellectually entertaining if you are familiar with certain fields. Um, the person who writes them like makes comics that are kind of joking about a lot of different fields in STEM and more than that. But it does so in a very humorous and very approachable way, I think. Like even his like captions often have like extra notes about the comic, whether it's actually like scientific notes about it or like reference links or something, or just like side comments about it, which I find that when I'm in the mood to consume more information, I find it to be a pretty funny comic, even if I don't necessarily understand everything all the time. But it inspires me to keep working on, my STEM skills and whatnot, so that way I can actually understand them. Just because I'm like, I want to get the joke, but I also want to be able to like share the joke and not be like, oh, I don't know how to explain it. It was just funny, and then people are like, well, how is that funny? So rather than deal with that awkwardness, yeah. But yeah, highly recommend XKCD. If you're in the mood for nerdy comics, there's also Piled Higher and Deeper, which there's a character named Cecilia, actually, very fun. Don't mind me, I'm just cleaning my mouse before we get started. I am so very glad that you slept. This makes me very happy. This is a good way to start my basically last stream of Global Hack Week for this week. But yeah, point is, all those comics are a fun time. We're gonna go ahead and have some fun by turning that into the plots that we're gonna very quickly make. So we'll get into it. So I have the original XKCD Jupyter Notebook up. So if you were at my past Intro to Python stream, we set up a very basic Jupyter instance in our Visual Studio Code IDE, where all I did was just say, okay, I have made a virtual environment that will run my Jupyter Notebook, and I'm running it out of Visual Studio Code. And so now by naming them IPy and B files, I will automatically get some of this lovely like options here from code to markdown, etc., where I can like give things a title using markdown. And then I can also run things in separate cells. And so that's what I've preempted here. And so got a fuzzy in my nose. One of those things is how to actually use the XKCD plot mechanism. So let me go ahead and rerun some of these. And I'll run that. And run. Come on, you were working like 20 minutes ago. That's so funny. I have the environment up. Come on. You run. You run. Wow, you're not like cooperating with me. Shame. Let's restart it just in case. Um, yeah, it is very much a Matplotlib. I can see how you might have just dropped the plot. That was a really bad joke. I'm so sorry. I use virtual environment and not global Python because I make so many random Python projects. The last thing I want to do is open an old project and find out I have grossly made things horrible for myself. All right, there we go. Okay. So this is now working, but I'll show you how I got it working, where I just picked one of the tutorial plots that they had. And so now you can see there's like the squiggly line, not quite straight, somewhat of the handwriting that Randall Monroe has from XKCD. And then like the funny comics that he has. Like, as you can see, they can be very intelligent and they can also be like my overall health. And then realizing I could cook bacon whenever I wanted. Which is inherently not exactly the healthiest thing to do all the time every day, but you can see like it's a fun little math joke about health. Obviously, please take care of yourself, all that jazz. And how I got this working is this is a nice little feature of Matplotlib, where if you have the fonts in your system, and depending on your Matplotlib instance, you do need to have like higher than 1.3 or something like that, or 1.30 or God, why does it have to be a fairly recent version? And you have the fonts, then it should work, but you may still need to reset the Matplotlib cache and delete a few files for it. We just need to force it to rebuild it. So what I had to do was I actually had to go into my, see if you can see it. Nope. You can't see this probably. I had to go through PowerShell and I had to go say like, hey, go find the Matplotlib cache that I have. I need you to go and delete that. So I actually had 2 caches, which kind of makes sense because I had, multiple instances of Matplotlib running. You might have more. You might actually have just a font list dash cache, which is the better thing to have. I deleted both of these with a remove command. Obviously, do one thing at a time. Be careful. You are messing with cached things. So you might also like copy the folder or something just in case you want to revert it or go back to it or just fix things. So as you can see, I had to delete things a couple times because I was uploading a few fonts that I was missing. So once I deleted that, when I restarted the kernel and reran everything, it was able to work. Now, what fonts specifically did I need? Well, let's go pull those up. That was, I have tab, right? Good job, me. I think I have it in a different tab. So there's a couple of things. There's the XKCD script font, then there's the XKCD font, and those are 2 that they also have font families with them. So I had to download those, and then because I'm on a Windows machine, if you open up your settings and you go find like font, you can drag in .ttf, .otf files, which are font files, or font family files. So I downloaded those. I also had to download Comic New, which is a variation of Comic Sans, but like better and less memey. And so I had to download that font family because, as you remember from the last stream that I was doing, I was having a lot of like, can't find XKCD font, can't find XKCD family, can't find this family, can't. And so I had to download those missing fonts, drag them into my Windows font manager, and then again delete those files from the Matplotlib cache, which is usually going to be under like your user account /matplotlib/ it might be in a deeper folder. For me, it was just upfront and personal in that one page, in that folder, where it was the font list. So font list dash cache, font list dash numbers. It varies for some people. I've noticed when I was looking into it online, but yeah. And so that's how I got this working, where now, as long as I use with, with plt.xkcd, where plt is referring to Matplotlib's pyplot functionality, as long as these things are within that function, and even if, let's say, I call plot.show or like I want you to display something, or what have you, then it will always show it in that style. If for whatever reason, like, so right now I'm not using like plot.show. I'm using, oh my goodness, stop giving me suggestions. We don't need those right now. I'm using plot in this instance. And so because I'm doing that within the width, then it will do it. But if I so happen to, let's say, put it on the outside, like, let's move this over. I moved this out and then of course the rest of the stuff on the bottom out, then it wouldn't actually render in the correct styling. So there might be other styles out there. I didn't have a chance to look. I've had a pretty busy weekend, to be honest, but that might be something of interest if you want to make plots fun for yourself. Being mindful, of course, that you still want to preserve readability, which again is where XKCD shines in having very simplistic diagrams, stick figures, etc. Valentine's Day is coming up. There's one where there's someone like spinning in the opposite direction of the Earth's spin, and they're like, if I just keep spinning, I'll reduce the Earth's spin just a little bit more so I can stay longer with you. Which I'm like, that's so cute as a nerd. But that's fun stuff. So that was a very, very simple way to, again, make some fun out of it. There's also the graph about superpowers, which these are pulled from the tutorials. I didn't want to think too hard about it because I don't have the capacity to come up with like good comics right now. But that might be something that you use in the future of like, oh, like I have a pretty funny like math pun or like math graph that I want to make. Now you can by using those tutorials that are out there and by using Matplotlib's customized features there. Okay. Fun stuff aside, there was actually serious things I wanted to teach you all, which was I wanted to show you how to process data, just by like getting a feel for it, because I know up till now, probably in these workshops, you've mostly just been either given a sample set or you know where to find a sample set. You don't really necessarily know how to make sense of it, especially when you have thousands of lines of data. You might be like, well, where do I start? Like, how do I work with this? And in the past, I've given like AI ethics and intro to data science kinds of things where I'm talking about how you might create a data set, you might create something or reference something, how to optimally use something. And this extends that a little more by being like, well, what if you don't have access to those things? Or what if the Kaggle data set you just downloaded doesn't have a very nice summary? How would you start to dig in without getting overwhelmed? And I realized I forgot to introduce myself. My name is Cecilia. I am a PhD student finishing up pretty much, already defended. I work with data constantly, but in a variety of different forms, and there's plenty other ways to work with data. So like this is both my bread and butter and not, because my degree is actually no longer in computing. I did social sciences work on engineers and engineering instead. So I have the background and I also have the software background, but now I'm forcing them to work together even though I didn't need to do it as much in my degree, and so on. But yeah. Yeah, sometimes I get comments, they're like, "You forgot to introduce yourself." And I'm like, "But I don't like to." So, I was like, "Oh, yeah, let me do that before I get away from this." Yeah, so we're processing data today, and then, I almost closed that tab, that was awkward. That would've been really, really awkward. And then we're gonna get into more about, like, basic plots, what you can do with Matplotlib, and how to extend those, abilities, features, etc. Again, being mindful of the time. We might not quite get to everything. We might speed run. I have some sample stuff up so I can just copy paste if things are going too slowly. But what I was going to get at with the introduction was, if you have questions, feel free to ask. I really encourage questions because if I can't explain it, I will show you how I will go figure out how to explain it. And that might be helpful for you if you find that you're stuck in asking questions and there's no one there to answer it for whatever reason. It's 2 a.m. or like you're in a spot where there's not a lot of technologists around you, or you're just like, I don't know how to ask this question. So I really encourage mutual learning from both sides, where I'm not only just teaching you, but you might be teaching me and like asking questions that I'm like, I don't know the answer. Let's go figure it out. Because I really prefer that humility of like, I don't know everything, but I like figuring things out. All right. So sample data. So I picked a pretty much random sample data set where I just went to Kaggle and I was like, pick the top rated, like cool one, whatever. And I thought, cars seem nice. My friend just got a new car that's like an old car and it looks really cool. And I was like, hey, let's play around with some car data, now that I'm inspired by him. and again, get a feel for like what's out there. Like, let's say I'm looking to make my own car, or I want to make an app that predicts things. Whatever it is I want to pivot to, whether it's for myself, for others, etc. Like, how do I get started? And so, um, if you have a Kaggle instance, then like you can go ahead and download it. If not, I did download a subset of them. I just processed it myself, and like I copied a decent amount and got it ready to go. Again, I was rather lazy, and I was like, I don't want the full thing. I just want like a decent amount to work with to showcase like you could work with a lot of data and how do you deal with it? Because reading this line by line, that is not fun. And if you're reading something line by line and it's just like binary values of like yes, no, or 1, 0, or true, false, you're not going to really make sense of that all that often. It's not easy to tell where there's missing data. It's not even easy to tell if there's like just consistency or that it's like been cleaned for you or not, especially when you look into the thousands of lines of data that there might be. And so one way might be to open this in Excel and then go start looking or what have you. But there are ways to kind of work with that. And so there's a couple ways that you can start to just access the data. Of course, the first one is just physically look at the file yourself. They won't always be in CSVs. They might be H5 files. They might be Excel files. They might be Word files. They might be a .text file. They might be TSVs. There are so many formats that people use to collect their data, and you'll basically have to adapt to it. And so normally, if I'm like working with just a simple spreadsheet or something, there is something that I tend to do, which is my default and how I started out with data before I really got into like the data science heavy things. I was like, oh, just import CSV. And then I'm going to go with open and I want to find that cars CSV file, which I already have it in this folder set up. I already have the environment on and everything. And I know that I'm going to want to set up a new line separator because I know it's going to be, as you saw in the other file, and this is something you would look for is like, how are these like lines separated? Is it new line? Is it something else? It could be tabbed. There are so many different formats people could use that are non-standard, which is super annoying. I'm going to name that as CSV file just for the sake of it. I'm going to go ahead and hit save. Let's see if it'll, yeah, I want to use this kernel. And so right now it's going to run and give me some errors. That's fine. I just wanted to showcase the highlighting. I realize I'm not super zoomed in right now, but I'm going to make a reader and it's going to be a CSV reader and then CSV file. And then I might have other information that I want it to use. Like, oh, I know my delimiter is going to be a comma instead of like a dash. Or what if I was using underscores because I had commas in my like numerical values, for example, and so on. And so I would also add the delimiter right off the bat. It's giving me the comma, and maybe I also have characters that are quoted. And right now, I really don't. Like if I'm looking at all these things, I don't have any quotations around things. But perhaps I might have a single quote around my string values, or I might have a double quote. And so that might be something of concern, especially if I'm like, oh, let's say semi-automatic hybrid transmission or something. Maybe there's like a list or something and we want them to actually use the full string, which means to ignore the comma when it's inside those strings. And so in doing that, we want to make sure that the delimiter is correcting for how this data is laid out. Now, again, this is fairly clean data, so we don't actually, I think, need this delimiter for quotations. And so that will pretty much be it for a reader, but depending again on what we're seeing, what we're looking at, just from those first few lines, we don't need to scroll through all 10,000 or however many lines there are. We'll find out actually how many in a bit. We just want to know like what's the structure of the data so that I can start parsing it and viewing it in a human readable way that isn't just like, I have 20,000 lines to read. Now, mind you, I'm a fast reader, but that's with context. I don't have context because I'm looking at a data file. I read just about as fast as the average person, which is I'm not going to read that at all because I can't process that. I'm not a computer. Maybe trained on it. So Copilot's helping me out, and it's saying, oh, for row in reader, go ahead and print things. And so let's say Yeah, let's go ahead and print it just to showcase that we are, again, printing things, that we are processing this data correctly. We know that we're going to have brand, model, year. This is our header, engine size. Nothing is splitting in weird ways. And so this is a good habit of like just seeing like as you're doing transformations on the data, one, that you're not changing the original file. Again, way back in the AI ethics workshop that I gave, never change the original data. But if you are applying transformations on it, you want to test to make sure that things are going, of course, correctly. So we are seeing, like, okay, these numbers are actually being treated as strings right now. This might be important later to fix up. So this is one way that I would start looking at data, by breaking it into like the header versus the individual values, etc. But there is, in fact, a simpler way to do this, because if I printed every single line, I would be miserable. I'm going to start a new code block, and we're going to use a different library, which I don't think I have it actually set up in here. We're going to import pandas as PD, which is a popular file management. As you can see, it's giving me DF, or data frame, pd.read CSV. And so since it's auto-completing for me, I mean, like, hey, that's pretty great. And we're going to go ahead and hit print. But I'm pretty sure things are not installed. So let me go and pip install pandas. And once that installs, I'll go ahead and run the kernel for that specific cell. Wow, the hour goes so fast. Oh no. Rough. That's really rough, y'all. We have so much content to get through. Now I'm like, are we gonna get through everything? Oh no. Um, and I know this isn't Matplotlib yet, but I just wanted to again show you that there's different ways to interact with things. Okay, so it's installed. We're gonna go ahead and run it, and now it's like nicely formatted. Like we didn't have to do any of that this time around, but we would have if we wanted to look at the data up just with a normal import CSV. So Pandas actually lets you work with a variety of different file types, so it's a very popular choice for folks to use. As you can see, there's like, you can actually like read this. That's the point I'm getting at. It's readable. It's super separated. Like we kind of get what's going on. Like it's much easier to be like, oh, we might have like different options if we wanted to say like, oh, there's manual, there's automatic, there's semi-automatic, there's hybrid later on. I think no, these are just transmissions. My bad. The point is like this is a nicer way to look at things, and then it also has a continuation of the other fields, which is where that slash is. Or we might have more information about the mileages and how many doors and the prices and so on and so forth. And it's also telling us there are over 5,000 rows and there are 10 columns. So this is a nice fail-safe check for you to be like, is this actually what I'm seeing in my data? If I were to go ahead and count things or look at things, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 headers. And if I scrolled all the way down, it would tell me, okay, I have 5,936 rows, which is, a nice fail-safe again, double checking. Where if we remove that first row as our header, we now actually have the 5,935 that they found. So yay, that's good. That means Pandas has done our job for us, made it really super pretty. And then let's say like we want to play with the data some more. We actually, again, using these cells, we now have this cached in our history. We don't need to re-import anything. We don't need to rerun anything. It's now just stored in cache for us to play with and do those transformation tests. So there's a couple of different things you can do with the data frame itself. There's also different things you can do with how many rows you might want to display. Let's say you didn't want to display all 5,935 rows. Instead, you want to just display the first 10. That would be a PD options change that you would do where you're like, oh, display only the max rows of 10, which would look something. I'm going to keep it commented because I don't want to rerun this, but you might say PD options display max columns. We actually want rows. So we're going to do max rows and we're going to say 10. And that would be something that we could do to just like immediately cut off this whole like, 0, 1, 2, 3, 4, ... 5,900. And this is a way that, again, you can get a little chunk of your data at a time, previewing things in a nicely formatted manner. So we're not running that, but it would, if I reran this, it would only show me the first 10 rows. The thing I wanted to show you was the different options you might have, which is the first one is data frame head, the number of rows that you want to select. So this is another way you can do it if you don't have those max rows set up yet. Let's say I only want to select, let's say I only want 3 rows. And so again, it has this nice formatting. I can see everything. We love it. It's so readable. It's so friendly. That's so nice. But what if we also want to see the last 3 values? You want to get the first and last view. And so you can do a print around things. You can do There's a couple ways you can showcase. Again, Jupyter is very nice. It will give you um, two sorts of approaches. So again, this is where I used print. The other one, it just automatically formatted it. That's the nice thing about Jupyter. So other things I might do instead of head and tail is maybe I want to see a summary of my data. And so I probably use describe, where describe, let's see what it will show me if I don't use print. I don't know. Yeah, so it shows me summary statistics. So right off the bat, it's giving me a lot of different information about the numerical values or the continuous values that are available and not the categorical values, which are like, oh, what type of engine is it? You know, what type of, instead it gives me, you know, how many things it counts. Okay, that's great for sanity checking. We can get the mean of the year. We can get the mean of the engine size, the mileage, the doors. We can get the 25th percentile. We get the max. And this is super nice, especially if you're not comfortable with doing statistics, but this is something that I would be doing in my PhD where I'm getting descriptive statistics of my data. Now, if I wanted to choose a subset of things, I'd have to do some more finagling, do it manually myself, etc. But this gives you a nice quick overview that isn't necessarily always available on certain data sets. And so other things, as you can see, we have a subset of our columns. Let's say we had maybe, you know, 500 columns for whatever reason. We can also go ahead and say columns. And it will give us, oh, come on. You looked earlier. Oh, perhaps I'm not using it right. But there's a way to get the columns that I'm clearly not, oh, it's because it's not a function. It's because I'm doing the operation. There we go. So let's say I wanted to just get the list of columns that we could possibly have. Maybe because I want to eventually pick which columns I want to work with as I'm doing my plotting in Matplotlib. Like maybe I'm going to correlate engine size to fuel type or engine size to price, and I want to see what it could look like as I start to compare those independent variables, seeing if there is actually a dependency, correlation, etc. And so again, statistics-wise or like categorically, however you're trying to build your plots, these columns are really helpful because you can choose those things from your data frame. So that way you can actually merge it in. Yeah, so quick preview of Pandas done. Again, my goal was just how would you break down a data set into something that you can actually use. We're pretty much done with this example. It really was just meant to be like a very, very fast blurb about like, here's how you can finagle your data into things that you want, where we get into Matplotlib, where our goal is just like, what kind of things can you do with Matplotlib? And the answer is quite a bit. But depending on your use cases, you might actually find that Matplotlib may not completely meet your needs for a variety of reasons. Maybe it's because it's not the best dynamic plotting library, though it does have animations. It may not be as live as you want it to be, in which case you might consider Plotly or some other libraries that are out there. Some just have smoother graphics, and that's okay. Every library has its own benefit. But different folks use different libraries for different reasons. And so again, if Matplotlib doesn't meet your reasons, then that's okay. But it is a good place to get started. There's a lot of transferable understanding in what you're working with. All right. So we're going to go ahead and select the kernel again. We want to make sure that we're running the right things. And since we are using Matplotlib, reference file I wanted to use. All right. So originally I was pulling in some examples from, I'm going to paste this and explain it line by line because I didn't do that last time. I pulled some stuff from their tutorial because I wanted to be as close to what their examples are, so that way it's just easier to have another perspective on it. I'm not using the XKCD this time, though it would be very easy to just show things. But you can see that we can now have categorical variables, things that are not numbers, things that are, you know, segmented in some way. You can do counts, you can do rates, you can do all sorts of things. You can also change the colors on your plots, which depending on where you're working, you might prefer to use primary colors. You might be trying to do accessible design. You might be trying to call attention to a specific thing. And this is where those graphic design skills that you're starting to build at various other instances come and play a role. And I'm not showing you the plot just yet, getting to the plot, if you will, because my goal is to make sure that you understand that all the things that you just manually draw out, you can do programmatically, of course. And so you can see that there's labels, there's colors, and then there's actually plotting it itself, which is this ax.bar, where you have your categories, you have the values that you're going to draw, you have whatever the labels are going to be, which you've predetermined here, and then you have the color that you're associating with them. So this can also be programmatically done, where you might pass this in from a secondary application, AI, machine learning model, etc., where you might want to showcase like, oh, here's how many things you got correct. Here's how many things you got wrong. Here's where it stumbled for longer, or the training period, or something. And then you can, of course, label your figures, where, of course, you set the Y label. This is your X label, by the way, the bar labels. You can set a title, always important for a graph, and then you have your legend, which, of course, you have a title for that. The thing you're most often going to use is this plot.show to make sure that all the things that you've put together and drawn, if you're familiar with any form of like Pygame libraries, or if you've worked with other things that you need to draw or render things first before you show it, you need to remember to show it in the first place. And so that's where that plot.show is. So a lot of the drawing things that happen in the background of Matplotlib, and this is actually something I've done a lot of research on for a very long time, years ago. It works a lot like rendering for monitor screens, or like GPU to screen. These days, AI is the new thing to like interject in things, but back in my day, quote unquote, the way that things work with graphics is first you prepare the next screen behind the existing pixels. And then in the second frame, that's when they swap and you're preparing the next screen, and the one that you pre-prepared is coming up. And so that's why like FPS is important, and ping and all these other things, because it determines how fast rendering happens. And all the other processes that are going on, which rendering is a very, very intensive processing thing that happens. Matplotlib is also doing it somewhat similarly, where you are building your frame before you show it, where that like replacement is happening. Not the best example and not the best way to explain it, because it has been a while since I've had to explain it in layman terms. Like, I know it at a very, very technical level. Like, that is not stuff we have time for. That would actually be a very fun stream to just like show how graphics work. That would take a lot of planning though. But as you can see, there's all sorts of like colors. You can see all the like supply, etc. Very simple bar graph. And so now we can start to mess with this. Or maybe we want to change the counts. Or maybe we want to change the scale. Or maybe we want to change the colors or the labels. Or we want to change the titles, the Y labels, etc. And so there's plenty else you can do. You can also make it monocolored, where in that case, you might just comment out that bar colors. You might, excuse me, also just get rid of the bar labels, and instead you might just have, let me adjust this. Maybe instead you might just set a generic X label where you have fruit kind or something like that. And so that's one way that we can start to change things. Let's go ahead and rerun it. And so now we have this neutral blue color. We can get rid of the legend because there's no more colors to work with. So let's comment that out. And obviously nothing else has changed. We just have a different way of representing things. And so again, things are automatically labeled, apple, blueberry, cherry, orange, all that stuff, which is, nice. And so let's say we want to change this into a like horizontal bar for whatever reason. So we just change that to bar H, and then we go ahead and run that. And now we just have that sideways histogram style bar chart, which is nice. Now, let's say you wanted to have a line, like a lined plot, or you wanted to do more of like a stacked. There are additional ways in which you might make that. And so I have another reference of this one. Again, these are copied from the tutorials because, again, I wanted things to just work, but I also wanted to show you different ways you might do it. So this one's using NumPy or NumPy as a library to process a lot of these arrays. And so you'll end up working with NumPy a lot in Matplotlib as you arrange arrays in directions that you need them to go, which is where that data transformations comment I made comes from. Never, never, never edit your original data source. As you can see, I'm not working with cars right now. I wanted things working, and I'm like, these numbers are on scales that I just don't want to deal with right now. I want something plain and simple that works. But it's very easy to just process things or replace the numbers in your plots, which again is the versatility of Matplotlib, where maybe I might, instead of boys, girls, and then the standard deviations or something like that. And then of course you have np.arrange, which is a, let's see if it'll get me to, come on. There we go. So a range, this is not great documentation, unfortunately. But I think this is referring to like the indices that we want to reference. And so I'll go ahead and run that. And so this is a very interesting plot where it's stacked. We now have a comparison between the contributions of the boys versus the girls and the teams that they have. And we could change the colors where right now by default it's just giving us arbitrary colors. Again, we could go through and we could change things using the colors in probably the AX generator, or let's see, the plot generator. Let's see. So we have P1, we have the bar, and so we have the two bars that are being drawn. And remember that plot show is always here on the bottom. It's the last thing you do when you are done with your plot. You want to make sure that people can see that chart. And you also see these ticks, where these ticks are actually these little dashes here, where it's showcasing the separation or maybe the standard deviations between them. Again, these were calculated preemptively ahead of time. This is a great way to get familiar with Matplotlib by just playing with the tutorials, seeing how they mean, and then gradually integrating your own data sets into them and seeing how they plot and how they work and whatnot. Because again, your goal is like, how do you represent your data in a way that people understand it? Because people will not understand your whole 5,000 line data set or 20,000 line data set. They'll understand graphs that summarize things for you. Can confirm, when I did my PhD defense, like one of my committee members, like the man just wanted to see graphs, and I was like, here are your graphs. I hate these. And they're like, yeah, I was really wondering when your graphs were going to show up. And I'm like, okay, like that's fine. Some people just prefer visual representations of numbers. Some people don't. It really depends on your field, on what you're doing, and the story that you're trying to tell. And so numbers really help with impact, with really showing you the scale at which something is occurring, whether it's on a really small scale or a really big scale, and then relative to what the understanding is of that scale. So for our understanding, like, okay, like, we've got some number of scores, perhaps, maybe it's like basketball or something for like elementary, who knows? But this impact might obviously mean something to someone in, a girls versus boys teams, especially if it's like a sports team and so on. And I also have a line plot example where we're going to mess with this one a little bit. I didn't want to mess too much with this one, but this time we're not using NumPy or anything with it. NumPy. I never remember how to pronounce it correctly. People don't really talk to me about it. So, but yeah, so line plots are going to probably be your bread and butter more so than the categorical bar charts that I showed. Like bar charts are probably going to be very common for me because I work with a lot of categorical variables, but most everyone works with continuous variables, which are predictions. And so you'll have line plots to show like lines of prediction along with a scatter plot, or you might have regression lines or showing like how far off of something and the best line of fit. This is really common in machine learning, and especially as you're doing prediction-based models. You might also see it in training on like the accuracy level versus the training data, etc. And sorry, my watch is going off. People are yapping. Yeah, so currently it just has some sample data where you have your X values and your Y values, which if you're working with a coordinate plane before, then this is fairly common where you'll just have like, oh, normally this might actually look more like, oh, it's a tuple of like X comma Y. And again, there's different ways you can do this. And this is something that you can, excuse me. This is something that like NumPy might help you with arranging if you did get those values as tuples, because again, how it's plotted and how it's valued. But as you can see currently here, they just have, X values, Y values, putting it back into a tuple anyway. Again, depending on what you're using will determine like what you will end up needing and how you use these functions. Let's see. And so you can get your scales. As you can see, there's the data itself. And so we have also the line style, the color style, like markers on them, and like how big in pixels the line is going to be. So I'm going to go ahead and comment this one out. Come on. And then, yeah. So as you can see, there's actually two lines going on right now where I was fiddling with things earlier and I was like, I'll just put them in the same cell. So we have a simple line plot. We have our y-axis, our x-axis, etc. We just have our very, blue normal line, not dashed. But maybe we want to switch things up and we're, showcasing different lines where we want it to be red, we want dashes, we want all the points to be marked with like closed dots, and so on. And so you can change these obviously in the different things you can do, like maybe I want a marker of an X, maybe I want it to be blue, and maybe I'm fine with the line style as it is. Let's see if it cooperates. So now I can replace those dots with X markers in case that's important. You could probably even make a map, like you probably could, and I would not be surprised. But what if I have two plot dot plots? Well, now they're drawing on top of each other, and so now you can see in the background there's that light blue dash, light blue solid line that we had earlier. So we can plot multiple lines. And so if we were just using the same values, of course, they're going to just stack on top of each other. But let's say we had, in this instance, which I commented out, let's say I, had an additional set of Y values, because again, maybe I have at time, maybe the training versus the correction value, or maybe I have, what else can I do? There's another example I mentioned earlier that I'm totally blanking on. Again, line of best fit, based on what you're getting from a training sample, or maybe there's like time dependent things or otherwise. And so your time value may not change, but the numbers on your experiment may. And so you might say, like, here's 3 trials of the same experiment, same timings. However, here's the things that we changed. And so you'd have your legend that tells you which line is which. So I'll go ahead and let's comment that out. And so I'll re-render it, and now we have our 2 different lines. Again, you can showcase a lot of different information on just one graph, being mindful that if you show too much information, people will not get it. So obviously this is a simple line plot example. We know that the goal is to show us an example, but if this is like the same lines but shifted, we'd have to explain what's going on, whether by being clear in our Y and X axes, our title, or a legend, or some way of basically indicating that if somebody glances at this for 30 seconds, they will relatively get what's going on if they're in the same field. Chances are, if they're not in the same field, there will be a little bit of extra difficulty. But yes, you can change the labels as you would anytime. Don't forget the title. Always remember to show, blah, blah, blah. Usual stuff. Okay, so what else can you do? And the answer is everything. You can do more stuff. Like, let's say you wanted to show a pie chart. And I have another example of this, again, pulled from various tutorials where my goal was just like, let's walk through these things so that way you know what's going on. And so this might actually... So there's a lot of things going on that I've set up in this one. I've merged a few of the lines because I really wanted to... I knew I would run out of time. Where we have our labels and we have the percentages or the sizes. So obviously these add up to, 100. But what happens if we make one bigger than the other for, giggles? Doesn't really matter. It doesn't really show us. However, that's not good math. So don't be mindful if you're going to use pie charts. And to be honest, if you are making a pie chart, chances are you can probably do it in a bar graph. Just unless there's a very real reason you need a pie chart, like demographics, which demographics is really hard to show in a pie chart, because you lose a lot of that detail in those like 0.01 point something percents. So it's actually not recommended to use pie charts all that often, but I just wanted to show you that you could. You could even make your pizza or something, since that was apparently a meme that happened. But again, you use different types of subplots going on. So this breaks out that subplots into the figures and the axis. And so we're using x.pie instead of x.bar or bar h, or like our line plot, I believe, was just plot. And so again, different ways to interact with this. But you just plop in the data, plop in the labels, and now here's the customizability. Like, let's say I got rid of all this. Let's leave this as that and see what it does. And so this will give us our default pie chart, random colors, random spacing, all that stuff. And so if I wanted to instead, let's say I wanted to ensure that people knew what the percentages were on the pie chart, then I would have to have this auto percent here, where I have formatted text. And so you can see that these are all now inside the pie chart. Very nice, very friendly. Okay, great. But what if there's not enough contrast? What if like these are just too small to put inside the pie chart? We want to make sure that it's outside if it's too small. Well, you can actually change the percentage distance from things, the label distance. You can also change, of course, the colors like we did show originally. Or again, breaking this down, there's just customizations that you can do even after you've done the default, just render the chart. And so you can see, these percentages are farther outside. Now the labels are inside. And again, there's variations to what you can do to display the story of your data. I keep mentioning story because storytelling is really important when you're working with data, particularly with human data. There is usually a story behind what you're doing. And if there's not, you might be in a field that does not require stories, in which case, great. But personally, I feel like stories are really important so that way you really understand the meaning of your data, the impact of it, etc., and you can make the most out of your data in a respectful way, hopefully. So you'll notice that I didn't really have to do plot.show this time. And that's just because I didn't want to. Was lazy. Yeah. There's more things we can do to it. So we're going to go ahead and show you that as well. But I'm going to... I saw this and I was like, this is really funny. And no one will ever use this. But you can also do patterns, which is disorienting. And I hate looking at this. But you could do patterns if you wanted to. You just have to type in the pattern of text that you want to use, where, as you can see, these are all patterns. You can wallpaper your graphs. I don't know why you'd want to do it, but you can. And then there's this other bit where maybe you want to change the spacing or change even like where the where it's rendered. I'm just gonna do that. Oops. So maybe you want to pull a triangle out, right? Oh, I broke it. I broke it. Hang on. Let's see. Let's see if that works. Yeah, there we go. Nope, that's not quite it. Where's the little explode? Oh, it's because I did this again. Let's do that. There's some duplicates. There we go. So now if you wanted to pay special attention to a specific point in your pie chart, so you can see there's some weird graphic stuff going on. There's some artifacting actually in the direct center here where that like red is crossing over. Like you don't need to pull this out like this at any time really, but if you wanted to, you could. It's called exploding something out. And you can change like which one you want to explode and how far. Let's say I wanted to actually explode at 0.5 and it'll change the distance. And now it's super duper far away for some reason. I wouldn't recommend it being that far. But point is, you can, again, tell your story with your data. And then the thing I wanted to get to, I know we're at the 10-minute mark, but the thing I actually wanted to get to that I care more about, not about plots, but actually about computer vision, is that you can load images into Matplotlib. And so you can also, come on, code. Don't know why that broke. Sometimes it doesn't like me. No, no, no. I don't want to generate. I want to code. Delete. Okay. So I already have a preloaded image, but you can open up images in Matplotlib and you can start to adjust them, make changes to them. It's actually not common that you would use Matplotlib itself to open an image. Classic meme. It's not common to use Matplotlib. It's just not. Instead, you would use it as a byproduct. Instead, you'll probably use this imshow a lot, but you will probably use the library Pillow, where Pillow lets you do a lot more. And again, you can remove the axes, add the axes, whatever you want to do. There's a couple different things you can do. But like I said, you are probably more likely to use Pillow. And that is through this code, where from Pillow, import the image. We have our file name. There are simpler ways to do this. You could even just straight up do image.open file name, convert as you like, and then deal with the arrays themselves. But this is what I really wanted to show you. Like, let's say I wanted to grayscale things, right? This is Matplotlib based, where after I've loaded the image, things are great and wonderful. Now I can make it grayscale. Or like I actually went to SciPy's cookbook to look at all the different color maps that Matplotlib has available. And so there's stuff like autumn. You just have to get rid of the vmin and max here. But now I can like recolor images. And so if you're getting into computer vision, training images, you might actually iterate through a series of images intending to like neutralize colors in some way or fashion to optimize your model for a specific way of rendering things. Like maybe using grayscale is often very common as a way to better find contours, edges, lines, etc., as a way to process images when they're at their smallest pieces. And so the things that stand out, of course, are going to be those corners and edges. Whereas if you're using a full color image, you now have a more complex image because you have those 3 or 4 channels if they're using RGB and or alpha. which is a lot to process. So you might simplify images, reduce the dimensions as you process something through computer vision. And this is more of a passion project for me at this point. But there are many, many ways to interact with this. And I could, of course, turn off the axes here. But if I were going to be labeling something, so if I'm labeling images for computer vision, maybe I'm drawing a bounding box, maybe I'm like choosing an image and saying, yes, this is weird, or no, we should recolor it, or yes, has this thing that we're looking for if it's a classification problem. All sorts of different ways to do it. Let's say I wanted to draw a rectangle. You would actually be using patches. And this is actually, again, something I've personally done, where you want to draw a rectangle on top of it. I'm going to actually go ahead and do another instance because, again, I have this code and we are motoring so fast because we're running out of time. But same thing, just image open. There's, again, ways to cut this down. I've pre-sized this rectangle. I didn't want to spend time on stream finagling with it. But the way this works is it takes the X, Y coordinate and then however additional many pixels you want to have the rectangle be. And so you can see I've drawn a rectangle here. So we have the 100 at the relatively 50 mark. And so we have 50 on the X-axis, 100 on the Y-axis, and then I've extended it out about 400 and 300 pixels each. Again, showing that I wanted to maybe label something, like maybe I'm looking for the dimensions of her glasses stem or something, or maybe I'm looking to label something specifically. Now, this is a very manual process of you fiddling around with it. There are ways not through Jupyter that you can label images where you have to basically spin up your own instance of Tkinter or TKAG or something like that, and you need to homebrew your own Python instance so you can actually get into this is I know way too much about Matplotlib rendering. But the point is, you can actually use a mouse to draw things. It is just extremely gimmicky because of the rendering frames, and it can't handle too much, which sucks. But fun fact for you, in case you ever decide you want to label your images, there's probably a tool out there that does it for you. But depending on the data dimensions that you're working with, you may not necessarily be working with a 2D image like this. Maybe you're working with 5 dimensions because you're working with space-time data. Chew on that. And then the last thing I wanted to show you all was animations, where you can animate your graphs. And so again, I have some sample code, again, pulled from those tutorials. I wanted to just showcase them, where they're just generating an arbitrary sine wave. Again, if you're into radio or signals processing, etc., this might actually be your friend, particularly if you want to generate different waves that you want to have reference for, or that you're just trying to showcase sensor data in some way, especially as a voltage curve or something. Then this sets up your plot for you, and then you have a function that is animating, setting the data in this instance. And so again, Matplotlib, you can choose the different frames that you might want, whether it's you want 10 frames or some frames, or maybe you have other things that you'd like to run. And so it will take a minute, but you can choose all these different options. And so this is something you can consider if you wanted to embed it on your website, or you want to embed it in your project. As you can see, that it is a little bit janky. Those frames hurt. So animation may not be, it's possible in Matplotlib. And there are definitely ways to make it more efficient and better. I would not recommend doing animation Matplotlib, but the potential's there if you have not so complex data. Okay, and that was your overview / continuation of Intro to Python by doing an Intro to Matplotlib and how you might process data using Pandas. We really have gone over at a high conceptual level what's going on. You've had a XKCDFI process now installable on your computer if you want to make fun graphs that don't look perfectly straight and are perfect typefacing. But really appreciate y'all joining me. Let's see, who's coming up next, actually? I believe next up is Steven with his Exploring AI Models, Part 1. He's actually continuing the stuff that he was talking about this morning before today in Global Hack Week, so definitely show him some excitement, because I know he's really excited to continue on with I think they were doing a transformer model. And so he'll be doing that up next. But I want to give you all some time to take a break, get some water, get a snack. If you need to go to bed, go to bed. But otherwise, enjoy the rest of Global Hack Week, and I will probably see you all at closing. But in the meantime, enjoy it. Make sure you check in for all the things. That way you can get your stickers. and make the most of it. Have a great rest of your Global Hack Week. See y'all.